Thank you for viewing this web presentation. I'm Craig Fleischman, Physician Manager for this Quality Improvement Project on Documentation of Report Completeness, sponsored by IAC ECHO. The aim of this QI project is to provide a tool for the interpreting physician to improve the completeness and consistency of final reports by adhering to the requirements outlined in the IAC echocardiography standards. The goal of this project is to improve final report completeness to 95% within 1 year. On a review of 500 IAC echo accreditation applications, 195 or 39% of the submitted reports were incomplete. This resulted in delay in accreditation and has been the most consistent reason for sites' delay of accreditation. The echo report is considered the single most important part of the test in that it is the communication of the results of the test to the provider and is the link between clinical action and outcome. This project has been approved by the American Board of Pediatrics and is active through June 2016. Individual participation will be for 1 year. After successful completion, the physician will receive 25 points of performance in practice credit for maintenance of certification. This project is offered to all physicians in laboratories accredited by the IAC in pediatric transthoracic echocardiography. In looking at the Institute of Medicine quality dimensions, this project focuses on effectiveness. Let's review the requirements for successful completion of this project. This will include viewing this webcast, which you are doing now, followed by completing a 5-question quiz prior to beginning evaluation of your echo reports. We will then ask you to evaluate final reports of complete echocardiograms using a provided checklist. You will review at least 20 consecutive reports during the first quarter of this project and at least 10 consecutive reports for the subsequent 3 quarters. If more than one physician is participating at a site, physicians may cross-review each other's reports. You will submit the reports evaluated as well as the checklist to IAC for review on a quarterly basis. Here is an example of the checklist that you will be completing. We will go through this checklist section by section. In addition to evaluating the elements of a complete report, we'll also ask you to record the time spent participating in this project. Specifically, we will ask you to record the time spent reviewing the first 10 reports in the first quarter and compare that to time spent with the final 10 reports in the fourth quarter. Looking at the pediatric transthoracic echo report components, the report must be standardized for the lab using uniform diagnostic criteria and a standardized report format. The report must accurately reflect content and results of the study, including summary of the results of the examination and pertinent positive and negative findings. The report must be typewritten, including the printed name of the interpreting physician. The final report must be reviewed, signed, and dated manually or electronically by the interpreting physician. Electronic signatures must be password protected and indicate they are electronically recorded. Specifically, stamped signatures or signing by non-physician staff is unacceptable. And here's an example of the first part of the checklist that you will be completing. Next, we'll look at report components related to demographics. The report must include, but may not be limited to, the date of the study, name and/or identifier of the facility, patient height and weight for determination of body surface area, name and/or identifier of the patient, date of birth and/or age of the patient, primary indication for the study, name of the performing sonographer, name of the ordering physician and/or identifier, gender of the patient, and blood pressure. Systolic and diastolic blood pressure must be obtained on or around the time of the study and displayed on the report. And here are the corresponding sections of the checklist for the demographic section. Next, we'll look at some of the quantitative measurements that should be part of a complete report. And this will be two-dimensional and/or MOC numerical data. And this must include, but may not be limited, except where technically unobtainable, measurements of the left ventricular internal dimension or volume at end diastole, left ventricular dimension or volume at end systole, the left ventricular wall thickness at end diastole, ventricular septal thickness at end diastole, and aortic root dimensions. We acknowledge there may be physiologic states where these measurements are inappropriate or unattainable. In those situations, the not applicable box should be checked. Moving on to the Doppler components of the report. Reports of the Doppler evaluation must include, but need not be limited to, peak and mean stenotic gradients as appropriate, degree of regurgitation, peak tricuspid regurgitation velocity for estimation of right ventricular systolic pressure when possible, and any other pathology discovered by Doppler evaluation. As with the 2D MOC section, there may be times when these measurements may not be applicable. In this next section, I will discuss methods of process improvement that you can use in your lab to improve the percentage of completeness of the echo reports. I'll describe the use of PDSA, or Plan, Do, Study, Act cycles to test ideas and changes for learning and improvement within your lab. Specifically, we want to try small changes to meet an aim, identify a measure to determine if we're meeting the aim, and if we're not meeting our aim, come up with ideas of changes that we can make that will result in accomplishment of our aim. So, let's start with question one. What are we trying to accomplish? An aim is a specific, measurable, actionable, realistic statement of expected results of an improvement process. A strong, clear aim guides improvement efforts and is characterized as intentional, deliberate, concrete, unambiguous, specific and concrete, measurable with a numeric goal, agreed upon and supported by those involved, and when using these aims, make your aim actionable and useful. For this project, the overall aim is to improve the percentage of complete reports at your site. But for the PDSA cycles, you will look at smaller changes and smaller aims to address specific elements that may be deficient. For instance, if at your site blood pressure is not always recorded, you would want to modify your processes to more reliably include blood pressure in the final report. That may mean assigning a specific person to measure and record blood pressure, or assigning a person to specifically review a report for blood pressure inclusion. Or it may include having the checklist prominently displayed in the echo reading area so that the physician is reminded to specifically look at elements of the report that have been deficient in the lab. Next, we need to know what we're going to measure in order to determine if we're meeting our aim. So that brings us to question 2. How will we know that a change is an improvement? And that will be by measurement. And measurements are indicators of change. Several measures are usually required over the course of a project. In PDSA cycles, measurement used immediately after an idea or change has been tested helps determine its effect. Key measures and measurement should be directly linked to the goals, be integrated into daily work whenever possible, be graphically and visibly displayed, and for PDSA cycles, be simple enough to accomplish in short periods of time. The measures you choose to use will be dependent on the elements that may be deficient in your reports. For purposes of this project, We're interested in percentage of report completeness. For feedback, you will receive reports in this format showing report completeness for each submitted report, as well as aggregate completeness by quarter. And hopefully we'll be seeing an increasing trend of that completeness. So we have an aim, and we've identified measures to determine if we're achieving our aim. Next, we need to think of ideas that will result in improvement in percentage of report completeness. Which brings us to question 3. What changes can we make that will result in an improvement? So ideas for change or change concepts to be tested in a PDSA cycle can be derived from evidence or results of research and science, can be derived from critical creative thinking or observation of the current system, or may result from theories, questions, and hunches. When selecting ideas to test, consider the following. It should have a direct link to the aim and goals. There should be a likely impact of the change, and so you want to avoid potential low-impact changes for testing. There should be some potential for learning, and it may be better to have a series of tests that will build on one another, and therefore each particular test may be of a somewhat small scale and short cycle, but build upon the previous. So putting it all together, we start with planning. You should be objective with evaluation of first quarter results and developing a plan of implementing a small change. This will include identification of who will be responsible, what the change will be, where and when it will take place, and over what time period. Next, we move from plan to do. And at that point, we'll collect data as planned, document experience, problems, and surprises. Next comes study. So data is analyzed and compared to what was predicted as the outcome. Did something unexpected happen? What conclusions can you draw from this test of change? And finally, we come to act, which results in refinements and modifications to be used in the next cycle of testing. Ideally, you'll have a series of PDSA cycles that will lead you from your baseline to the goal of greater than 95% completeness of ECHO reports. Next then, let's talk about some tips to make the most of PDSA cycles and tests of change. First, think a couple of cycles ahead as you're planning your tests. And do more cycles at a smaller scale and faster pace rather than trying to do larger projects which will result in fewer cycles. Be innovative and flexible in order to make the test feasible. Collect useful and only just enough data during each test to make it efficient. Learn from failures as well as successes. Communicate what you've learned to your group and engage leadership support. Finally, this is an example of a sheet you may choose to modify or use to develop small tests of change in your lab. Thank you for viewing this webinar and participating in this QI project. Please click on the Take a Brief Quiz button to take a 5-question quiz.